Assalamualaikum and good day. Okay. Um hari ni kita proses lagi Vision 172 Structure Analysis chapter 2 we are in week 4, jadi kita masuk chapter 2 Bending Stress and Shearing Stress. So we are looking into this new chapter Okay. Stresses in beams. When beam is subjected to lateral loads, it bends until either a state of equilibrium. Stresses induced in fiber are just below maximum permitted value. So either these two sama ada stress induced in the fiber are just below maximum permitted value ataupun beam fail. So sama ada tak hampir nak fail ataupun dia akan fail. Okay, now we look at bending stresses. Bending stresses are longitudinal stresses, for example, acting to the longitudinal axis of the beam, either tensile or compressive, and are induced by the application of bending moment. So the word here, I'm going to sebut dia as P because I cannot pronounce this word well. Jadi I sebut dia as P. Okay, what does it mean by this? Because you have a beam like this, okay, for example, and you have like couple of forces here acting directly on the top of the beam, okay, and then usually because bila kita sebab you belajar kan bending moment, you belajar shear force before, so you know from the force dia akan translate into moment because this force bila dia jadi moment dia akan cause rotation. So that's why kita kena kira dia, kita jadikan dia as a moment lah macam tu. So bila dia transfer here, kenapa dia transfer? Because of you have the support here. Okay. So dia akan transfer here. Dia akan distribute to the support all the forces and it might cause rotation. Okay, bila dia cause this rotation, maksudnya rotation tu apa? Because of bending. So maksudnya bending ni dia you punya the beam itself akan bend because of these forces, because of the rotation itself Jadi bila dia transfer to the support here, okay, you see here acting P to the longitudinal axis. So longitudinal axis maksudnya axis yang memanjang lah of the beam, either tensile or compressive, as in tensile ataupun compressive maksudnya sama ada tensile force ataupun compressive force lah. Okay, sama ada dia akan pulling up ataupun push down macam tu, and are induced by the application of bending moment. Okay, maksudnya sekarang kalau you tengok to the longitudinal axis of the beam. Okay, so bila moment ni dia being transferred here, okay, therefore you see because of ini longitudinal ni as in yang tegak ni lah, maksudnya longitude kan, longitude ni longitude longitude. Okay, this is latitude kan. Okay, jadi longitude yang tegak ni. Okay, so bila tegak ni, that's why dia acting P to the longitudinal axis of the beam. So ni tegak, okay, acting on the longitudinal axis of the beam tu maksud dia. Okay, jadi that's on the bending stress. Okay, now we look at shearing stress. For shearing stress are lateral or longitudinal stresses acting tangentially to the plane of reference and are induced by the application of shearing force. So sebenarnya dia lebih kurang sama sahajalah. Okay, even yang this one kalau you nampak dia acting to the longitudinal axis of the beam, because sebenarnya kalau you cut longitude maksudnya you cut this part of the beam, you akan nampak because dia transfer dia macam ni so dia transfer macam ni lah, being transferred kan to the other side maksudnya dekat ke arah support. Jadi sebenarnya dia being transferred like this, therefore dia dia sama arah dengan bukan sama, selari dengan longitudinal axis. However, for this one, for shearing stress, the acting tangentially to the plane of references. So plane of references, what does it mean? Maksudnya plane of references you inilah. Okay, so this is plane of reference and are induced by the application of shearing force. Okay, jadi ini adalah plane of reference. Jadi the tangential which is 90 degrees. So kat situ beza dia. Okay, so now we going to look at the formula for bending stresses. So this is the formula. F is equal to my divided by my divided by I. So F we call it as bending stress, and then M is maximum bending moment. Okay, and then Y is distance from centroid, and IXX adalah second moment area. Okay, when you see the formula like this, so you know that you need to find maximum bending moment and also IXX. Ini adalah benda yang penting. That's why I minta you to revise balik on this subject, maksudnya IXX and BMD, SFT ni semua, so that you know how to calculate. Okay, but to actually increase you punya understanding, we're going to look at the example later on. Okay, tau equal to SAY divided by IT. Say it. Okay, we look at one by one. This tau, nampak simbol tau ni, maksudnya ini adalah shearing stress that we're going to calculate. And then we need to find the maximum shear force, which as you know, we need to draw the SFD so that kita tahulah berapa maximum shear force. And then A is area above point. So nanti ada kan point that you kena kira area dia. And then Y is distance of centroid of the above area measured from central axis of the section. This is quite complicated to explain later. When we do exercise, kita akan lebih faham. Okay, and I is second moment area, which is IXX. And T is thickness of that point. So that is for shearing stress, the formula. Okay, now we look at example number 1. So example number 1, a timber beam having a cross section of 50 by 100 mm is loaded as shown. Calculate the bending stress and calculate the shear stress. So this question asks you to find the bending stress and also the shear stress. And this is the cross section area. Okay, so ini adalah simply supported beam. As you can see, you nampak kat sini ada support and ada support RL and RR. So because of kenapa dia bagi macam ni, sebab you nanti kena kira berapa maximum bending moment and berapa maximum shear force. Kita dah tahu our formula, which is for bending stress and also for shear stress, we have to find the IXX. Okay, because of kita ada formula yang my I and also say it. Okay, jadi I kat sini kita kena cari IXX. Okay, so this is our cross section of the beam, 50 by 100 mm. Since this is just a simple beam design, maksudnya design dia hanya rectangular saja, jadi you just boleh simply use this formula of IXX, which is BD cube divided by 12. So 50 divided by 100 cube bahagi dengan 12. So you dapat 4.167 times 10 power of 6. And then we need to find the reaction in order to calculate for SFD and BMD, sebab kita nak draw later. I tak tahu macam mana, maybe pun Dr. Izzat ada ajar you cara different way than mine, but this is how I calculate. So first I say that total moment dekat R is equal to 0 because I take the moment here. So meaning that I take moment here, so it is equal to 0, meaning it is equilibrium. And then RL going to RR, maksudnya RL darab dengan, sebab kita nak kira moment kan, because this is moment equation, so everything is in moment. Therefore, kita darab dengan 10 meter because of kita tahu force darab dengan distance adalah moment. Ini pun semua force darab distance. Force darab distance. So, RL darab dengan 10 meter and then going to the right which is clockwise. Jadi, dia positif lah. Okay. And then we have 5 kilonewton darab dengan 7 meter. However, this is counterclockwise. Therefore, dia negatif. And then you have 5 kilonewton darab dengan 3 meter which is counterclockwise juga. That's why dia negative equal to 0. Okay, if let's say you pakai cara Dr. Izzat, betul sama saja sebab end up the answer will be the same. RR ni tak masuk juga dalam this moment equation. Sebab RR ni memang dekat sini. So distance dia kosong kan. So RR ni totally cancel out. So that's why kita dapat solve this equation because RR darab kosong tetap RR adalah kosong lah kan. Maksudnya RR darab kosong sebab distance tak ada kat sini because kita ambil moment dekat this point. Therefore that's why RR ni not count together dalam this moment equation And then since kita dah dapat RL which is 5 kilonewton here. Therefore so kita boleh dapatkan RR lah. Okay. Using the force equation. So total force y-axis is equal to 0 meaning equilibrium. Okay, whatever force coming downwards will be pushed upwards Jadi that's why dia kosong. RL naik atas. Okay, so positive. And then minus 5 kilonewton because they're going down, negative. Going down again 5 kilonewton, negative. And then plus with RR yang kita nak dapatkan ni. Okay, jadi masukkan saja RL ni dah 5. So 5 minus 5 minus 5. Therefore, you akan dapat negative 5 plus RR. Okay, therefore RR adalah 5 kilonewton. Okay, next kita akan lukis SFD and BMD since kita dah dapat value of RL and RR. Okay, jadi kita EC terus replace RL ni and RR with the value. Okay, so this is I draw it. Okay, since 5 kilonewton going up, you see here going up, positive. And then there is no force, therefore dia straight line sahaja. And then you meet another 5 kilonewton which is going down, so dia back to 0. And then there is no force, okay. And then going down 5 kilonewton since you meet another 5 kilonewton load. And then dia akan go straight lah since tak ada force lagi yang acting at this area That's why negative 5. Okay, jadi kat sini you jumpa RR which is 5 kilonewton, dia going back to 0. So maksudnya balance lah. Dia start dengan 0, dia akan akhir dengan 0. Tu cara you check betul ke tak you draw SFD and BMD. Lepas kita draw SFD, we need to draw BMD also sebab kita nak kira juga for bending stress which is dia perlukan maximum bending moment. Kita akan start dengan 0 and we need to calculate area of this. Okay, so berapa area kat sini, macam mana you kira? So you dah ada value 5 darab dengan 3 meter because this is 5 kilonewton kan, darab 3 meter, so you akan dapat 15 kilonewton meter lah. So that's why I tulis 15 kilonewton meter. And same goes with this area, you pun have to calculate the area. So negative 5 times 3 meter. Okay, therefore jawapan dia negative 15 kilonewton meter. Start dengan kosong for BMD and going up because this is positive, area ni dekat atas so dia positive. And then tak ada any area so dia go straight line. Area kat sini kosong tak ada, go straight line. And then dia ada negative 15, maksudnya you kena tolak 15. Jadi dia go back to 0. Daripada you punya drawing kat sini, you can see that the maximum shear force adalah 5 and 15 kilonewton meter ini. Okay, maximum shear force and maximum bending moment. We go to kita boleh dah calculate bending stress since kita dah done with this calculation of IXX and maximum shear force and maximum bending moment. Okay, you boleh choose to calculate bending stress dulu ataupun you can choose to calculate shearing stress dulu. Tapi I akan calculate bending stress dulu First you need to draw you punya beam ni and then you terus marking lah berapa sebenarnya dia punya dimension. Sorry. Okay, this is 50 and this is 100. Okay, first you akan dividekan this beam ni into 5 points. Okay, dividekan dia. So I dividekan A, B, C, D and E. Kenapa 5 points? Because markah dia 5. Jadi kita divide 5 points lah. You boleh buat garisan ni lah. Okay, garisan ni. And then kita akan kira by this point. So that's why nampak ada FA. Maksudnya bending stress for point A, for point B, point C, point D and point E. We look at for point A. We know that the formula for bending stress is my divided by I. Okay, my ni apa? M ni adalah maximum bending moment, which is kita dah kira sebelum ni 15 kilonewton meter. Okay, therefore kita nak tukar kilonewton into newton. That's why I darab 10 kuasa 3 darab 1000 and also meter to millimeter I tukar. That's why I darab 10 kuasa 3. Okay, that's why jadi 10 kuasa 6 lah kat sini. Sebab kita convert And then we have Y. So what does it mean? What Y ni distance from centroid. Okay, maksudnya right now you have point A here. Okay, centroid obviously you pun tahu this is rectangular, meaning centroid must be in the middle here. Okay, jadi point A sampai centroid adalah 50 sebab 100 divide by 2 you dapat 50. So kat sini lah 50 tu. And then you divide with IXX, which is yang you dah calculated sebelum ni, 4.167 times 10 power of 6. So you can simply cancel out this 10 kuasa 3 and 10 kuasa 3 ni dengan 10 kuasa 6 kat bawah ni. And you boleh kira terus, you akan dapat 179.866. Okay, why I tulis compression? Because value yang kita dapat ni positif. So when the value is positive, dia akan jadi compression. And then we look at point B. So for point B sama juga, you need to look at this from centroid, okay, and then to point B. Okay, so point B must be here. So if let's say half of this is 50, okay, and then dah tentulah A sampai B adalah 25, so B sampai C adalah 25 sebab kita divide dia sama. Jadi distance daripada centroid ke B adalah 25, which is kenapa dia positif? Lupa nak cakap, because of dia above C, point above C, distance ni kita consider dia as positif. Okay, jadi 25 lah. Sama juga cara for M, and then for I masukkan juga sama lagi, you kira saja, you will get the value and then value positive, meaning this is compression. Okay, next we look at for point C. So for point C sama juga, I will explain why tu saja. For Y, so since C ni dekat centroid, C ni maksud dia bukan centroid, C ni sebenarnya adalah point. You boleh namakan dia apa saja, but since dia dah C and centroid, so dah tersama lah. So point C ni memang dekat centroid. So bila dekat centroid, so distance from C to centroid memang dah dia dekat situ juga, so kosong lah. Okay, jadi that's why dia akan jadi kosong. And then for point D, okay, if you see for point D, this is 25, since daripada centroid ke bawah ni adalah 50. Ya, jadi this is 100 kan. So 50. Jadi 25 D nak ke centroid. That's why negative 25 because it is below centroid. Below centroid dia automatic become negative. And then you darab, you dapat negative 89.993 actually. But since kita takkan letak value tu in negative because negative tu doesn't mean anything. It means tension. Maksud dia bila you dapat kira sebab kat sini you darab dengan negatif, dia akan dapat value yang negatif lah. Negative 89.993. Tapi it doesn't mean it is negative. It means that it is in tension. Okay. Jadi letaklah tension dekat tepi tu. Maintain calculation you dalam positif. For point E, so daripada E nak ke centroid, which is this is 50 lah. Okay, that's why negative 50 below centroid, so negative. And then you darab, you akan dapat jawapan dia negative 179.866. But negative means tension, so I leave it positive like that, but put tension in the bracket. Okay, itu jawab macam mana cara you kira. The next thing we need to do is we need to plot this diagram. Okay, bending stress punya diagram. To plot this thing sama je. Okay, this garisan tengah ni adalah kosong. 179.866 dia adalah positif. Okay, so dia belah kanan And then you have 89.993 dia positif. Dia belah kanan. And then you have negative 89.993. Dia negatif sebab dia in tension, so dia belah kiri. And 179.866 the tension dia belah kiri juga. So you akan dapat drawing like this lah. Okay, according to this point calculation yang dah kira kat atas, you plot it into this diagram. And then don't forget to tulis lah which one is compression and which one is tension. And if you see the value for A sama dengan value E, cuma beza dia bawah ni E you dapat dalam negatif, and value for B dia akan sama dengan value of D, cuma beza dia negatif and positif lah. Compression ataupun tension. Why? Sebab you divide it symmetrically, you divide dia sama, jadi dia akan reflect balik whatever the value yang you dapat dekat bawah. A akan sama dengan E, D akan sama dengan B, cuma beza dia positif and negatif tension or compression. So itu beza dia. We are done with the bending stress. We're going to look at shear stress. So for shear stress, same juga, you kena draw tanda lah each point kat mana and all. Okay, and then here I also tulis lah. Okay, for 50 mm and this is 100 mm. Okay, ini complicated sikit Tadi kita dah kira, so kita akan pakai tau A, say it. 5 darab 10 kuasa 3, so S ni adalah maximum shear force. So maximum shear force kita 5 kN. So 5 kN tukar to Newton darab 10 kuasa 3. A is area above point. Jadi area above A. So sekarang kita tengah kira shear stress for area above A, which is tak ada area above A tak ada sebab beam you kat bawah. Tak ada area atas, jadi kosong. Y is centroid for area above A ke centroid semua. Okay, centroid semua you pun tahu dia memang C dekat sini lah. Okay, centroid dekat C ni kan, mana dekat centroid dekat sini lah, dekat tengah-tengah. Kalau dah tak ada area above A, macam mana nak ada centroid dia kan? Jadi kosong lah. Okay, and then divide by I and times T. So I is 4.167, masih sama XX, and T is 50, which is the thickness. Thickness tu maksudnya B ni 50 mm ni lah. That's why you tulis 50 mm and then you darab dapat 0. And then we going to look at point B. Point B I lukis lah. So ini adalah area for point B. Area above point B maksudnya. Okay, so that's why keluar 50 darab dengan 25. Okay, kenapa? Because of 50 lebar ni darab dengan 25 dia punya ketinggian area above B ni lah. Okay, kalau you tengok ini 25 kan. Ini 25, ini 25, ini 25. That's why jadi 100 total height dia. That's why 50 times 25. Area above B adalah 50 darab 25. Distance from centroid of area above B pergi ke semua ni. Centroid semua. Which is centroid of this beam. Which means dekat C ni lah. So how you calculate? So 25 divide by 2. So you akan dapat 12.5. Okay. Ini you tahu adalah 25. Jadi 25 campur 12.5 you akan dapat 37.5. And divide sama juga dengan dia punya I and value of T. Because of I dia masih sama and T thickness ni masih lagi 50. Jadi samalah. You calculate, you will get this value. For tau C ataupun shear stress point C, area above C, semua ni. We have 50 darab dengan 50. So ini area. And then darab with Y, which is centroid of area above C, which is somewhere dekat point B ni lah. Okay. Ke centroid semua dekat sini. So ini adalah 25. So ini adalah Y. Divide with I and T sama je. And then we look at D. For 4D, area above D dekat sini. Area above D is here. Alright. So for area above D, you have 50 darab dengan 75 sebab 25 campur 25 campur 25, 75. For Y, this is A and this is Y. Okay, 12.5 tu macam mana you kira? So centroid semua dekat C So area above D ni semua ni lah. Okay. Jadi centroid of area above D ni, it is somewhere mungkin somewhere in between C and B dekat sini. Okay. Betul tak? Okay, jadi you nak dapatkan distance ni. Kan, sebab you tahu kan kalau you ada like macam ni, ini 75. Okay, ini 50 Okay, 75. So centroid dia dekat mana? Centroid dia dekat tengah ni lah. Okay, so separuh 75 bagi 2, you akan dapat 37.5 dengan 37.5. Separuh daripada area above D ni. So centroid dia in between lah, tengah-tengah kan. So kalau 37.5 kat sini, okay, kalau you kira daripada atas ni juga, okay, daripada atas ni ke area semua ni, okay, sini, ini adalah 50. 100 di, sebab separuh kan daripada 100, so 50. So centroid semua 50. Beza dia macam mana you nak kira ni? Berapa you nak dapat? Macam mana you nak dapatkan ni? So kalau you tahu daripada atas ke tengah ni, centroid semua 50. Daripada atas ke centroid above D adalah 37.5. Jadi 50 tolak 37.5, you akan dapat 12.5. That's how I get this value. Okay, so I dapat 1.125 when I calculate all lah. And last kali, you have area above E, which is semua ni semua ni. Area above E. Okay, so 50 darab 100 semualah. This is 50, this is 100 and this is 50. Darab dengan kosong. Kenapa Y kosong? Sebab centroid of area above E adalah dekat tengah ni. Centroid semua pun adalah dekat tengah juga. Jadi there's no distance, so it becomes 0. Okay, so done. We are done. And then the next step is you need to plot. Okay, plot shearing stress diagram. To plot it, so you just buat garisan lah, which is mean this is 0. And then 1.125, so I plot lah 1.125, 1.5 and 1 for each point. Okay, tengok dekat D I letak lah berapa value dia. Dekat C and dekat B I letak ikut value this one. And then E point dapat 0. So dia akan Simetri. Nampak memang kalau dekat sini dia kasi simetri bahagi sama. Okay. Because kita punya beam ni rectangular and kita divide dia sama point. Jadi dia akan jadi drawing dia macam ni lah. We have like tutorial number 1. So for this tutorial not exactly tutorial sebenarnya, this is exercise exercise that we going to do together masa kelas kelas tutorial nanti. So during that class, what I'm hoping is that you akan buat dulu this example, try dululah. Then we going to discuss it together masa dalam kelas. Okay, jadi you boleh discuss dengan saya lah macam mana cara you kira sama-sama dengan saya. Okay, soalan ni sama je. Soalan ni saya akan bagi sekali masa handout. So you can check the handout given in the GC for your reference. Okay, hopefully semua okay on that. Okay, thank you so much everyone and have a nice day.